link to the appliance, and have the VMs within that appliance now go use this real link. So they can go grab real web pages, you could go get real callbacks, all that kind of stuff is possible. So you can get a little bit more intelligence out of either things artifacts you recover in the field, or artifacts that you maybe capture through one of our other appliances. So to give you an idea of kind of the data that we're going to give you, so right off the bat, I just have a sample web exploit up here. We're going to give you the PCAPs that occurred both on the wire and within our VM networking infrastructure. So you'll get to see the difference of the two, and get to see like what payloads were transferred over the wire and everything like that. We will also give you the original objects themselves. So it's a little hard to see, it's a little blurry, but that archived object list will contain everything that was part of the original set of flows. So if you want to reconstitute the attack and do your own forensics, you should have all the information you need to do that. We will also give you all the infection URLs. So if we look at this big long list here, that was essentially what lived in our proxy server that allowed us to rebuild the attack, and the one in bold is the one that contained the actual exploit. Everything else is just a separate, you can see a whole bunch of EXEs, for example. Those are obviously called in probably post-exploit. So we have all these other OS change details that we will display as well. So if you've ever played with the dynamic analysis system, which I'm assuming most of you probably have, very similar output. We will also highlight some things though. So you can see these little malicious alerts in light blue. That's kind of us adding some color for those that aren't familiar with how to interpret some of this data. But some key things that we can do here is, like for DLLs, for example, we can tell you what the entry points are. And that's because we run things in context, we're able to have that data, right? So we're able to load things or say unencrypt an encrypted EXE because we have the exploit that can do that for us. Where if you're trying to take the DLL by itself, assuming it's not encrypted, you will have difficulties there a lot of times. This is another example. This is a recent PDF 0-day. I think this is around January, late January, early February, if memory serves. This is one we found in the field live. The one example I highlight here is it goes to sleep for 15,000 seconds. So we can do things like track that as well as potentially trick it into thinking that much time has passed. So we do of course do things like that as well. Other things we might be able to flag on are if it's doing a debugger check, if it tries to figure out it's in a virtual machine, those are all behaviors that we can flag on and or avoid. So we can do a lot of stuff around that. If we flip over to the MAS, we still get your PCAPs, you get your original objects, but because we're not performance bound on that platform, we can give you some additional things that you can optionally turn on. So the first would be your extracted files. So we can take a snapshot of the file system on our VM before we start, we call it a work order, before we start the run, and then we can take the difference of what it was like afterwards and provide that to you. So if you have access to all the files that changed during that run. Within that archive, you can also turn on our per process memory dumps. So any process that's altered during the run, its memory will be dumped and be included in that archive if you enable that feature. You can also turn on a flash movie clip. So if you wanted to look at the desktop of the machine, maybe the bad guy forgot to include a library. I see that sometimes. Or you'll get the error message that it couldn't find whatever it was looking for to load. Those are useful. The other thing I would use the clip for is we support AutoIt. And if you're not familiar with AutoIt, it's like a user automation scripting language. It's pretty simple and straightforward. But we support that on the product. So if you wanted to, say, analyze an EXE or a PDF or something with some specific behaviors, you can program that in. And then that clip is useful to help you build that workflow because you get to see the window names and what it's waiting for and all that kind of stuff. You will get the same extracted callback information here. The only difference in MAS is it might be real callback information if you were in live mode. So whereas if I'm in Sandbox on one of the other platforms, I'll probably get an error 404 or something back on what I'm trying to, on what the VM requests. In here, if I'm in live mode, I should get the real response, which could be interesting as well. And then similar to the other products, you'll get the full dynamic analysis information. Additionally, on the other products, you're only going to get the dynamic analysis information for things that are malicious. On this product, you get it no matter what. It'll tell you whether or not we would have classified it bad on other products through a little flag we would set, but you're going to get that information either way. So to give you a quick snapshot of what the deployment looks like, it's pretty straightforward, and there's not a lot of configuration on these appliances. Generally, it's going to take you longer to rack and cable up the thing physically than it is to get it going. You walk through a little 13-step wizard and you're done. It's very straightforward. So where we typically deploy is pre-NAT, so we want to make sure we get your original source IPs, and it'll go as high up in the network where that condition exists, which typically will be either off the inside interface of a firewall or off the client-facing interface of a proxy server. Either one of those will work. For our email product, we just want to sit after the first cut of anti-spam and anti-AV. Other than that, we don't really care. We can support BCC as well, so if you don't want to go inline with the mail flow, you could send us a global blind carbon copy off of one of the upstream MTAs, and that is an out-of-band way of installing that product. Same thing for web. If you want to go out-of-band, you can do it off the span port. You don't have to be inline. And then our last product, which I didn't really talk about, because conceptually it's very similar to MAS, is our file product. So it mounts file shares and watches them for changes and analyzes the files in that share as they change. I'll just close with this. One of the great things about all the data that we have is that we're able to leverage it with lots of different technologies. So it's not just about us finding things. We can take that, turn it around, and then make other products in the network a little bit smarter, right? So I can take a lot of our data, like say I have that huge OS change summary. There's all sorts of URLs in there. I can parse those out and put in blocking rules on something like Blue Coat, for example, right? So we can take a lot of our intelligence to then make these other devices enforce a blocking action or maybe log something more heavily, whatever it may be. Our data is very valuable for that purpose. And then, of course, SIM is a natural fit. So we've had really great success there. Splunk's probably been one of the bigger ones. And that's about it. If you guys have any questions, we'll be out at the booth over there. But have a good show.